Today we're going to talk about two different types of exponents that are kind of important ones. The first one is pretty simple. We're talking about the zero exponents. So the first question is, how would you simplify x to the third divided by x to the third? Well, we have two ways. First, we could look at this as x times x times x is x to the third. X times x times x is x to the third. And if you think about it, when I'm dividing and simplifying fractions, x divided by x becomes 1, so it kind of cancels. X divided by x becomes 1, so it cancels. X divided by x becomes 1, so it cancels, really, which means the answer is 1. The other way of looking at this is our mad-spam rules. When we did division of same bases, basically what we had to do was just take our exponents and subtract them. And this gives me x to the 0 power. Well, from a second ago, we just saw that when we did this out, we ended up getting the number 1. So what do you think x to the 0 equals once we get to this point? Well, anytime you have x or any number to the 0 power, that is going to equal 1. So those are two different ways to get to the answer. Anytime you have a base to a 0, you get the answer of a 1, with the exception of a 0 base, which we'll talk about quickly in 1 second. So I've kind of plugged in the next chart here just so we can talk about it and not have me try to write on it while we go. So the algebra way of looking at this is a to the 0. So basically any number, which is my base a, with the exception of right here when a's are 0. So if this base is anything but 0, once you put it to the 0 power, the answer is a 1. So if a is 0, we get this thing over here called undefined. If 0 is the base raised to the 0 power, we call it undefined. Not 0, it's undefined. In words, for any non-zero a, so again the non-zero means as long as a is not 0, then we get a to the 0 is 1. And then a number example would just be 4 to the 0 is 1. So let's take a quick look at a couple of examples. So when I first look at this first example, 0.35, we might think, oh, that's difficult because it's a decimal base. Well, really it's not, because when we look at the base, the 0 power right here, remember the exponent always affects what it's right next to. There are no parentheses there, so it's just taking this base to the 0 power. Anything to the 0 power is 1. There's my answer. So the second one, when I look at this one, again, looks a little bit difficult because I see decimals being multiplied together, which seems a little bit confusing. But again, remember our mad-spam rules. If I have same base multiplying, I just take my exponents and I add them together. So if I have a base of negative 8.5, and if I add negative 4 plus 4, I get negative 8.5 to the 0 power. And just like we said a moment ago, the negative is inside, so the 0 is going to go to the parentheses. This whole thing is going to the 0 power, which means, again, my answer is 1. This last one you're going to be careful about, because sometimes we get excited and we say, oh, 0 power means 1. Well, again, think about what the exponent is going to. This 0 is only affecting the x. It is not connected to the negative 5. There are no parentheses that would include both the negative 5 and the x. So we got to be careful on this one. This is an easy one to jump quickly. So the negative 5 has nothing to do with that exponent. However, the 0 does do something to the x, and anything raised to the 0 power turns that into a 1. Now I can use my order of operations and put this one together. This is one you're going to be careful not to go too quickly on because we think this is super easy and we just have to whip through these. You still have to think about what does the 0 affect. If it hits parentheses, it would go to everything inside the parentheses. If it just hits a number or just hits a variable, then you only affect the variable or that number. This next one. So how would you simplify x to the 4th over x to the 6th? Okay, so we're going to do like we did up top. X to the 4th would look like 4 x's being multiplied together. Then we'd have 6 x's being multiplied together. So like we did above, if I'm reducing common factors, x's divided by x's, cancels, 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 cancels. So think about what we have here. We have a 1 in my numerator. All those x's canceled to 1's. So there's nothing left in the numerator. I still have to put a place of a 1. Down in the denominator, I have 2 x's being multiplied. So I'm going to put x squared. Well, the other way to look at this is our mad spam rules. We have the same base, and we are dividing. What we said was subtract your exponents. And that's going to give me -2 for an exponent. So what I want you to notice here real quickly before we say what this answer looks like, -2 as an exponent does not make my answer negative. One of the common things that we see every year is that we see a -2 and we think, oh, the answer is negative. It has nothing to do with it being negative. And maybe we can see that with this example here. What we have is one way of doing it got us to this number. This isn't negative. This has now turned it into a fraction. It's kind of flipped it upside down. This is the same thing as this because we did the same steps, just a different way. So what I want us to notice here when we start talking about this one is that x to the -2 did not change the sign. It simply turned it into a little bit of a fraction. We want to keep that in mind when we start talking about these negative exponents. So a negative exponent does not make our answer negative. So here we have a chart. This one's important to kind of really look at. We'll talk some examples in a second. So a to the -n. This is the algebra way of looking at it. Anytime I have some base not 0, so again, notice it says not 0. If the base is not 0, being raised to a negative exponent, notice what's going to happen. There is no negative sign being added over here. It does not make it become negative. What it's going to do is it's going to take this base, which is really a over 1, and flip it upside down to become 1 over a. And then notice my exponent has become positive. So something happens to the negative, but it disappears when it flips over the base. So in words, it's a little bit messy here, any integer n, a to the n is the reciprocal of an. Confusing, don't worry about that so much, we'll see some examples. And then lastly, here would be an example. So if I was to say to you 4 to the -3rd power. So the -3rd power does not say make it negative. What it says is take the base, which is 4 over 1, and flip it upside down to become 1 over 4. And then the -3, once you've done the flip over, becomes positive. Then if you wanted to multiply this one out and evaluate it, this would be 1/4 times 1/4 times 1/4, which is really 1 to the 4 to the 3rd power, or 1/64. So let's just see some examples, and maybe it will make a little bit more sense as you see some. So on the first one, we have 3 to the -4th. So 3 to the -4th, the -4 is affecting the 3. So we are going to take it. The base of 3 is really 3 over 1 to the -4th. So the negative exponent says flip over your base. So we're going to flip it over. It's now 3 over 1. I'm sorry, it went from 3 over 1 to 1 over 3. The -4 then becomes positive. So the first part of the question says write this as a positive exponent. We did that. There's your positive exponent, 1/3 to the 4th. Sometimes you'll see it written as 1 to the 3 over 4 at this point. Either one of those is fine. The second part says to evaluate, which means we want the full answer. So remember, I would keep the 1, because there's nothing up in the top happening to the 1. 3 to the 4th is not 12. They were not multiplying. Remember, it's 3 times 3 times 3 times 3, which is 81. So there's your answer when I had to evaluate that, 1 over 81. On the next one. So again, you have a couple ways of doing this one. You could have done it the way we first did up at the top and write out all the 6's, write out all the 8's, cancel out things. But the other way of seeing it is mad spam. In the mad spam rules, remember we said same base, you would subtract the exponents, So that's the same thing as 2 to the negative 2 power. But we want our answer as a positive exponent. So while that looks simplified, we want the answer as a positive exponent. So then we got to remember, 2 raised to the negative 2 does not make my answer negative. What it does is it takes the base, which is 2 over 1, and flips it over to give the reciprocal. Now it's raised to the second power. The other way of seeing this one, the other way you could write this is it's 1 over 2 squared. So there's the answer to the first part with a positive exponent. The second part says evaluate. So evaluating means 1 over 2 squared, which is 4. So there's the evaluate part. Now this last one. This last one's a little bit tricky. I could definitely do the mad span rules, but I want to show you this other way because especially as we get more complicated ones, this might be a way to try to help understand how this can be helped out a little bit quicker. So we have 9y to the negative third. So the first thing I have to think about is, what is this negative third affecting? Is it affecting the y or the 9 or both the 9y's? It's only affecting the y, right? Because it's not hitting the 9. There is no parentheses here that would make it hit both. It's just going to the y's. Then I have this other thing down here, the y to the fifth. So here's the easier way, I think, to do this. What I want to think about is, on all of these over here, when we had the negative over here, we basically said flip it over. So if I think about that, right now, if this y is up in the numerator, and I was to flip it, where would it land? It would go down into the denominator, correct? So one of the ways to help this is to take a problem like this one and say, my first move is going to be flip down anything that has a negative exponent. That will make it positive. So I'm flipping it over, doing the reciprocal. If it's in the numerator, it's going to land in the denominator. Now, if I had one in the denominator and I flipped it, it would land in the numerator. So here's how this one would look after I've done that first move. Now, the y's have disappeared out of the numerator because we flipped them down. The 9 stays because it doesn't get impacted by that negative 3. So in the denominator, I would now have the 5, and I've now added the 3. Think about that for a second, see if that makes some sense. The negative 3 up in the numerator, when I do the reciprocal, it's now a positive 3 in the denominator. And then, if I look at my mad spam rules, I can simplify this right here. I have same base as y's being multiplied, so I would just add the exponents to get y to the 8th in the denominator. Now the second part says to evaluate. I can't do anything to evaluate this. This is my answer. And this one's a tricky one. This is one that we'll see some more complicated ones as we do some of these problems. But think about what the negative exponent does. It does not make your answer negative. It does a reciprocal of the base that it's affecting. And then we have a real life problem we want to talk about. We have a drop of water leaks from a faucet every second. How many liters of water leaks from the faucet in 1 hour? So 1 hour we want to pay attention to. Over here, we're given the picture of the faucet. We're told that it is 5 to the negative second liters for every drop. So we know what 1 drop is worth. We know that it happens every second, and we want to know how many liters of water in an hour. So let's first look at how many seconds are in an hour. Because what we're talking about is the liters. This drop is coming out every second, but we want the answer in hours. So we got to think about, well, how many seconds are in an hour? So we can kind of look that first. So what we know about an hour is this. We have 1 hour. Okay. There are 60 minutes per hour. So if I multiply 1 hour times 60, it would tell me how many minutes there are, which would be 60. But I also know that every minute has 60 seconds in it. Okay? So this, if I was just to multiply all of this out, would tell me how many seconds we have in an hour. If I was to multiply all the way across here, I get 3,600 seconds in an hour. Now, the reason I wrote the labels in here is just so you can see how this works. This hour cancels here. This minute cancels here. And that shows me how I went from 1 hour to the seconds, because the only thing left over here was the seconds. So that's how I know that my label is now in seconds. So now we know that we have 3,600 seconds in that hour. So what I'm going to do is take my 3,600, and I'm now going to multiply it by that 50, and L is for liters, and the drop is per second, so I probably should put this label over here. Then again, these seconds cancel out, which is going to give me the liters that we want, and I now just need to multiply that together. Now remember, 50 to the negative second power is really going to become that. Remember, the 50 flips over to become 1 over 50 to the second power. Well, 1 over 50 to the second power becomes 2,500 when I multiply 50 times 50. And then we just got to kind of figure out, well, how much do we want to simplify this? If I was to multiply that through, I get 3,600 over 2,500, which basically becomes 1.44 liters. So our answer basically is that there are that many liters in 1 hour leaking from the faucet. So again, the important part about this section is talking about the zero exponents, which make all of our bases become a 1, unless it's a zero base, which is then undefined, or the negative exponents. And the negative exponents take the base that it's affecting and they do the reciprocal. So that flips over the base, then the negative exponent becomes positive, and then you can evaluate it from there. Really think about this one as you're working through the problems this week to make sure that you understand how they're working. Be careful not just to jump to quick answers. Really think about what the exponent is affecting. If you have any questions, please feel free to ask. Email me, write to me, or we'll see you in class.